Hello everyone, welcome back to the case study series. Today we are going to solve a sixth question, that is Radha, an aspiring landscape designer, is tasked with creating a visually captive pool design that incorporates a unique arrangement of fountains. The challenge entails arranging the fountains in such a way that when water is thrown upwards, it forms a shape of a parabola. The graph of one such parabola is given below. See, this is a parabola what she are talking about, and this is the graph of that particular parabola. Okay, the height of the fountain which rod above the water level is 10 centimeter. That means this parabola's height, this rod is 10 centimeter. Okay, and this is the parabola which it forms. The equation of then the equation of the downward facing parabola representing the water fountain is given by p of x is equal to minus x square plus 5x minus 4. So, since x square is negative, the parabola is downwards. Based on the above information, answer the following. Find the zeros of the polynomial p of x from the graph. See, if you closely look into the graph intersects at 1 and 4. So, therefore, the first question answer I can write directly here. The answer for this is 1 and 4. Now, find the value of x at which the height attains maximum height. So, when you look into this graph, you can see here it has attained a maximum height, correct? That means since it is symmetric parabolas are basically, in this case, they are symmetric. So we can say the midpoint of this particular line means from here to here. At that point, it will attain a maximum height. Okay. So when you look into the graph, you can easily identify the midpoint between 2 and 3 is going to be 5. 5 by 2, sorry. So answer for this is 5 by 2. Two questions answers are done. Now next. The first one, okay, if h is the maximum height attained by the water stream from the water level of the pool, then find the value of h. That means the maximum height attained at this point, correct, which is 5 by 2. This I'm going to use in this particular equation, so I'll get the maximum height. Then at what points on the x-axis the height of the water above x-axis 2 meters. That means what they want at what time. See, this graph is not according to the measurement. If it was according to the measurement, we could have drawn it, but here you can guess. Okay, there are two possible. This is 2 meter, means imagine the 2 is here. So at this point it attains maximum height, or I can take here also. See, now this point attains a maximum height. Okay, but that's supposed to be here, and also it attains maximum height somewhere here. So two possible points we will get. Okay, so they want us to find those two possible points at which the parabola attains a maximum height. That means what? Here p of x is basically an equation representing a height, correct? So therefore p of x is equal to 2 here. Then we'll reframe the quadratic polynomial. Okay, let us try this. You'll understand when we start solving it. Okay, first two questions are already done, so we'll move to the third question. So when you move to the third question, according to this, so first question answer I will write, which is 1 and 4. Second question answer also we have found, that is 5 by 2. Okay, this also can be found by using one of the formula, that is minus p by 2a. If you use this formula also, we'll come to know the maximum height attained by that particular parabola. So let's move to the third question. In the third question A, so they have given 2 meters the maximum height, correct? So therefore p of x is equals to 2. It is b. Okay, let me solve b first. That means equation, what is the equation given? See, minus x square, right? Minus x square plus 5x minus 4 is equal to 2. So here, if I rearrange in the standard form, x square will take it other side because we want to change the sign here. So it becomes what? X square minus 5x plus 4 plus 2 is equal to 0. That means I have transposed everything to the other side. So when you do that, we will get x square minus 5x plus 6 is equal to 0. So you can use splitting the middle term or quadratic formula. If I use splitting the middle term, the factors are minus 2 and minus 3, right? So it becomes x minus 2 into x minus 3, which is equal to 0. So therefore x is equal to 2 and x is equal to 3. That means the 2 points at which the height of what attains 2 meter is 2 and 3. Okay, so that is the second question. Okay, So let's go to the or first question. As I have already discussed the first question, let me go to the solution. So what they want, if h is the maximum height attained by the water stream from the water level of the pool, find the value of h. We already know that at this particular point it attains the maximum height, and we know the coordinates of that point. So there x is equals to 5 by 2. Now we are going to substitute this in the formula. That means it becomes h of 5 by 2 because they want height and the equation is same. That is x square minus 5x. Okay, I'm changing the sign. Okay, x square minus, or else you can take it in the same way, minus x square plus 5x minus 4. So x will be 5 by 2, correct? So this becomes minus 5 by 2 whole square. See, minus I have kept outside. Okay, plus 5 into 5 by 2 minus 4. So if you further solve it, what we'll get in this case, 5 by 2 whole square will give you minus 25 by 4, because negative sign is outside the bracket. So then this will be plus 25 by 2 minus 4. If you take an LCM, this will make it into 2, this will make it into 4, because denominator should be 4, right? Here if I multiply 2 into 2, I'll get 4. Here no number means it is 1. 4 into 4 is 4 into 1 is 4. So I'll be getting minus 25 plus 50 minus 16 divided by 4. Now simplify it further. 25 minus 25 will be 25. 25 and 16 will give you 9. So 9 by 4 is the maximum height attained by that particular fountain. Okay, that's an answer for this.